Hello and welcome to the walking talking topic on fractions, question number 2 with me, Mr. Barton. Now you'll see, just for a laugh, I've already made a start on this particular question because only 2 of the questions are actually about fractions, but that's no reason why we shouldn't just have a quick look at this one before we crack on with that. Write down the smallest possible number by which 24 has to be multiplied to create a perfect square. Now you can do this using trial and improvement, but there's quite a nice way of doing this that involves prime factors. So I've just split 24 into a product of its prime factors and ended up with 2 times 2 times 2 times 3. Now, the thing about square numbers is that they are the same number times by themselves. So like 25 is 5 times 5 and 36 is 6 times 6. So how can we get a square number using what we've already got? Well, already from 24, we could split this into a 2 in that bracket, and let's have a 2 in that bracket. And then we've got a 2 here, but we don't have space for another 2 there, so we might need one of those there. And we could put a 3 in this bracket, but we don't have space for another 3 there. We don't have enough left over. So what we're missing to make it the same is we need a 2 there and a 3 there. And indeed, if you take 24 and if you times it by a missing 2 and a missing 3, otherwise known as 24 times by 6, then you end up with 144, which is a perfect square. So 6 is your answer for that one. Anyway, that was a little bonus. Let's get on with the fractions. Right, 12 over 99 as a recurring decimal. Now, often in exams, you get it the other way around. You get given a recurring decimal and have to write it as a fraction. But this time, they've flipped it on its head. Now, some of you may just know that straight away, and there is quite an advantage of learning all your recurring things when they're divided by 90 and 99 and 9 and so on. But if you don't, you're going to have to use the classic form of long division. But that's okay, it's not actually that bad. So I've got 99 and I want to see how many times it fits into 12. And I'm just going to build myself up a load of zeros just in case, see how many I need. And if you're doing 99 divided into something, it's worth getting your head around the 99 times table. And the 99 times table isn't too bad, because it's just like the 100 times table, but on the first time you take 1 off, and then on the second time you take 2 off, and then on the third time you take 3 off. And I think, to be honest with you, that might be all we need for this one, but let's have a look. How many times does 99 go into 12? It doesn't. Carry my 12 across. How many times does 99 go into 120? Well, it fits in one time to give us 99, and then what's left over? Well, I think we're missing 21. How many times does 99 fit into 210? Well, again, it fits in 2 times to give us 198, and then what are we missing? Well, I think we're missing another 12. And then look where we are here. We're back to this one. How many times does 99 fit into 120? Once. What's left over? 21. How many times does 99 fit into 210? Twice. What's left over? 12. And it's going to carry on. So you end up with 0.12121212, otherwise known as 0.12 recurring with a dot over both the 1 and the 2. And then finally, for this flipping tricky one, express 0.0025 as a fraction in its simplest terms. So I'll show you how I do these. I write them as a fraction straight away in a dodgy way that you should never do in your final answer. I'm going to write 0.0025 over 1. And then I'm going to use my golden rule of fractions. As long as I multiply the top and the bottom by the same thing, I can do whatever I like. So first, I'm going to make it 10, 100, 1,000 times bigger. So if I make it 10 times bigger, I get 0.25. 100 times bigger, 2.5. 1,000 times bigger, I'm going to get 25 on the top. And on the bottom, if I make 1,000 times bigger, I'm going to get 1,000 on the bottom. Already it's looking a bit nicer. Now let's see if we can simplify it. I'm going to divide top and bottom by 5. So I'm going to get 5 over 200. And then I'm going to divide top and bottom by 5 again, and I think I'm going to end up with 1 over 40 for my final answer for that one. Okay, done and dusted.